So what conditions make the square root of xy times the square root of x times the square root of y true? This is the kind of question that separates top mathematicians from those who just understand the techniques and the formulae that they learn in the classroom. Every student who's studied surds has seen this before, but what they don't notice is that this is only true under certain conditions. Can you figure out what they are? So if x and y are both negative, then this part is fine because x times y would be positive. And the square root of a positive number, we're happy with that. But if x and y are both negative, then this equality then doesn't make sense because the square root of a negative number, if x is negative, and the square root of another negative number, y, well, we can't take the square root of a negative number without introducing complex numbers, which we're not going to go there just yet. We're restricted here to x and y both being greater than or equal to 0. And you might say, okay, but yeah, so what? How does that help us? Well, this is actually quite important in certain questions, and especially when we start introducing more algebra underneath our square roots. And I'll give you an example. So here we need to figure out what conditions actually make this statement true. And if you're giving a final answer, this could actually affect your final answer if this is coming up mid-question. So with the first part, we can see that x would either have to be greater than or equal to 1 or less than or equal to -1 for this whole part to be positive. But we actually have stricter conditions here as well. This part is telling us that x would have to be greater than or equal to -1, and this part is telling us that x has to be greater than or equal to 1. The strictest condition that we have out of all of these for this whole thing to be true is that x has to be greater than or equal to -1 because it's the one that includes this, but also this, if x is less than or equal to -1, it makes the other parts untrue. So that cannot be included in our conditions and our final answer. Same with if x is equal to 0, because then if x equals 0, then 0 minus 1, and again, we're into complex numbers again. So that wouldn't work if we're looking for real solutions only as well. If you like this, let me know in the comments.